So let's say your consumer pulls in a message and it starts processing it, and then boom, something goes wrong. Maybe like the database is temporarily down, or maybe there's some sort of network hiccup, or maybe your code hit an unexpected edge case. I mean, any of these cases, or there are more cases as well. So in this case, the consumer won't be able to delete the particular message from the source queue. Why? Because the processing has not been completed for that particular message. So it can't simply go and delete the message from the source queue, because definitely if we delete the message from the source queue and it has not yet been processed, we are losing some sort of data, which we definitely don't want. So what happens is that after 30 seconds time, basically after this 30-second visibility timeout is reached, the message becomes visible in the source queue again, right? And then other consumers can also see this particular message. Those consumers will see that okay, this message is not yet been processed. So whichever consumer is free, they will again pull in that particular message, and then they'll try to process it. So this is sort of automatic retry built right into the queue system. Now here's a critical question. uh, let's say if this the reason because of which the processing failed in the first instance was some sort of intermittent issue, and it gets resolved after some time. In that case, again, after a certain number of retries, the message would get successful and the message would get deleted from the source queue. But what if there is some inherent bug in the code itself, the code processing code, or maybe there is some inherent bug in the type of data itself which you have received. For example, let's say your consumer processes certain data which accepts maybe event in milliseconds, but what you are getting over here is, let's say, events in nanoseconds, or maybe something which is not expected. So in those cases, even if you retry this particular message for 5 times, 6 times, 10 times, or n number of times, the message is actually going to fail, right? So in these kind of cases, we need some sort of protection, because what would happen is that if we do not have any protection, this message would keep on coming into the source queue. The consumers would be picking that particular message and keep on processing it, failing it, and then again going back to the source queue. So this will be leading to the wastage of the resources, and also starvation for other events, which messages which otherwise would have been picked up and processed in that time. So in this case, what we need to do is that we have a concept of receive count. Every time a message is pulled from the queue, what we do is that we increase the receive count by 1. Okay, so let's say the first time a consumer picks up message from the source queue, the receive count is increased by 1. If it fails and then again goes back to the source queue, and then again another consumer or maybe the same consumer picks it up again, we increase the receive count again, and so on. Now whenever you are configuring your queue, let's say source queue, uh, what would you would like to do is that you would set a variable called max receive count, which would set this value as, let's say, 5. In, for example, in my case, this has been set to 5. So whenever a message reaches 5 failed attempts, that means the consumer has not been able to process this particular message uh, properly by like around 5 times, then what would happen is that the queue system will say, okay, there is something seriously wrong with this message, and we are not going to keep this forever. So what it would do is that in that case, it would take this message from the consumer, and it would move this message to a special place, and this special place is dead letter queue. And these messages, once they reach dead letter queue, are called as poison messages. So what is a poison message? It is basically a message from the source queue that will always fail no matter how many times you try to process it. Okay, so like there are different types of there could be like different examples of it. For example, the data itself is wrong, which I mentioned. Like you require in the consumer, the logic is written in a way that it accepts date in, let's say, milliseconds, but you get date in, let's say, YYYY MMDD format. So definitely the consumer won't be able to parse those inputs. So that could be one form of poisoned message. There could be like incompatible schema or any sort of logical bugs, like division by zero error, any kind of errors or exceptions which your code is basically throwing or at the time of processing. So what happens is that without, let's say we didn't have this DLQ, what would have been the repercussions? Without a DLQ, these poison messages would have kept on coming in, I mean retrying, coming into the source queue, picked up by the consumer, and then again failing, and then again going back to the source queue. This would have led to a infinite loop, and also would have led to starvation for other genuine messages. Okay, and also waste of resources. So the DLQ basically isolates these problematic messages so that engineers can investigate, and then they can manually investigate like why the particular message has been in a DLQ. They can investigate it, fix it, and then they can replay those events. So once they replay those events, what would happen is that this would go back again to this part to publisher. The publisher will send this to the source queue, and then these will get processed again. So if at all the bug has, if the bug has been fixed, finally the message would be reaching this, going via this path. Now now there's uh, a more sophisticated pattern on this, and that is basically you making use of